This video is about the last chip on my Z80 computer which I haven't tested yet, which is the boot ROM. And the boot ROM doesn't actually get access from the CPU itself. It gets copied into the RAM and then the CPU runs a program that's loaded from it. So on the old 8800, you used to type in the bootloader program on the switches and then you'd run that, and then that would load your actual program from magnetic tape or paper tape or disk drive. And then later on, as EPROMs get cheaper, they used to put the bootloader program into an EPROM. And then the computer would load the bootloader program from the EPROM, and then it would go to magnetic tape or paper tape or disk drive, and it would automatically load your program in from that. So this is kind of the second stage of evolution which I'm demonstrating on this computer. So what I've got here is I've got my NOMAD80 computer here, then the circuit on here is a baud rate generator which I'm using, which will eventually be on a PCB like this, and it will actually plug into these sockets here on top, and it could be some connectors as well for RS-232 and parallel port, but that's in a later video when I get some PCBs made for that. And then I've got a UART to USB connector going into my computer, so I can use a terminal to access my computer over here. So just to demonstrate booting from the bootloader ROM, I first of all need to go into the Minicom program to get the terminal running on my laptop. And then when I switch on the computer, I need to hold down reset while going into user mode just to make sure the program count is at 0. Press this button to copy the data from the EPROM into the RAM. I just hit the reset button again because that makes sure it goes from address 0 all the way up to FFFF. And when that blue light comes on, it's copied. So you see it happens instantly because it's happening at 4 megahertz. So it's copying at 4 megabytes a second from ROM into RAM. And then when I want to actually come out of that, I have to switch off the copy option, hold down reset while coming out of user mode, and there you see it actually starts up the program which was in memory. So when most people write monitor programs, they'll write it as a command line interface, and you type in commands on the command line. But I wanted to make something which is a bit more interactive, so I can use keys to navigate around this, so I can move left and right in the addresses. I can move down the line or up a line, or I can move down a page of memory or up a page of memory. And as I'm in address mode, I can type in address. So if I type in 8000, that takes me to address where it's actually copied my program to actually run it up here. Or if I type in 4000, you see that I just go into an area of blank memory. Just behind here, there's a kill the bits program, which I've got, so I can type that in. I can type that in anywhere in memory I want, but I'll type that into address 0, because the kill the bit program requires you to run in the lower half of memory so that you're not using any of the upper 8 address LEDs, and then you can use those to actually play the kill the bit game. So in order to type it in, I have to press tab, and that then takes me into data mode. And now rather than entering an address which I want to jump to in memory, I enter the actual byte code into the address where I'm currently located. So I'll type that in here, 3E. It shouldn't take too long. FD3 89 2100 1680 01 08 00 1A 1A 1. So that's the kill the bit program which I've typed in now at address 0. So as I'm in data mode, I have to hit tab again, and you see it comes across to this other mode, which is where I can actually, if I wanted to, change the value of a register. So I could put 5678 as the D complement register, and it just changes that. So if I'm doing debugging, that might help with that mode there. So if I hit tab again, so now I'm in the execute mode. As you can see along the bottom of the screen, I get the options which I can use, and if I press G, it'll execute the program. But I don't want to press G at the minute because I'm not at address 0. So if I just type in 0000, that takes me to address 0, and I can press G to start the program. So when I press G, it starts the kill the bit program, Now you see there's an LED lit up, up over this side. I think I must have left a register with a funny value in it. So if I hit reset, it actually goes and starts the program again, but clears that bit. It may be that I've left something set on the parallel port, I don't know. But anyway, I can now play the kill the bit program. And from this angle, I'm not going to be able to do very well, unfortunately. Like that.